So yeah, I wanted to go over some few stuff so I don't think we had any really critical questions on routing because of the way uh, trying to set it up within Moodle for the assessment. It was a bit tricky. But I wanted to go over some few stuff, some critical questions that you might come across, within routing. Phase of the some of the distant vector routing, the algorithms, especially the Dijkstra algorithms that are used for shortest path calculations in terms of the metrics involved in routing packets from one point to another, and how they pretty much handle in terms of tabulations and assessment wise. So I got this application here that I use for to sketch most of the my network diagrams when it comes to some of those design scenarios. So actually, I do have the question here. I already have the diagram set up. So this happens to be a network diagram that I created that I'm going to be using to go over the routing questions. Okay. So I basically drew the whole of this using this application called Diagram. It's actually, yeah, it's Diagram. It's a German-based network design application. It's it's an open source, very, very reliable. And it's free. That's one of the good things. It's free of charge. You can just go to die.com and then download it, and you can use it for some of your network designs and what have you when the need comes up. So especially when you write reports, someday when you're working and as a network engineer, you need to put reports together. This application can really help you out. There are a whole bunch of them out there. There's vSphere by Microsoft. There are a whole bunch of other ones, but this is free. It's vSphere costs money. You have to buy the license for it. Obviously, you can pirate it if you want, but this is purely free of charge. So, I mean, what else? I mean, you need. So, anyways, so this diagram here basically was created on this platform over here, and it does have some of the also basic menus that you'd come across on any applications. Your file all the way to help, and then you do have shapes. Diagram shapes, texting. If you want to text put some text on a very on any diagram or any objects that you pick up, these are the key lines and your arrows that you might be needing. So this will probably be your cablings and your signalings that you might be needing for your diagrams. But the key things are mostly right over here, where you see your key network devices and their images. So you do have Cisco switches. You click down the down menu. If you click down the arrow, you can see a bunch of other emulated or so images of network devices that you might come across from network. So network stuff. You got your switches, your routers, your firewalls. What have you? A whole bunch of stuff, from switches, PR switches, network is general, miscellaneous, from home offices, a number of stuff. What else? Let me see. What else you got? Computers, laptop, desktop. The whole thing. So anyway, some of these applications are just designed to address a number of your network designs. So whatever you can think of within your network designs, it does accommodate it. So that's the beauty of it, So anyways, coming back to this diagram here, all that you do is you go to, so I need this diagram here is just more or less a one implementation. I call it an MPLS network. Maybe it could be an MPLS network from the ISPs. It could be any one of them: Vodafone, MTN, Sprint, Tigo, Verizon, you name them. Yep, all the guys out there that handles telcos. So it's just a simple, a bit elaborate though. And it does have all the various cost metrics associated to every route that a packet might take on route to a given destination. And we're going to be using that to answer a few questions. By the design is just about picking up your various key network devices. So I got routers, right? So I have to look for routers. If you put the cursors on them, it can tell you what the name of it is. A VPN gateway. That happens to be a PIX firewall, regular PIX firewalls, security appliances, firewalls, and what have you. So I'm looking for a router, right? The symbol for a router, you see the arrow goes. Actually, I'm using switches because router looks very a bit off. So but just keep in mind, these are routers. So if I wanted to pick one of these, I'm going to go with switches. Even though they are routers, I just want to be legibly. So I'm using one of these guys here. So just pick, no, I'm using the other ones. I'm using a layer 3 route, a switch. So it's one of these guys, I think, not these guys. So just pick it up, put it on a board. So this happens to be an environment where you can sketch your designs and what have you. So that happens to be an edge level switch router. So it's a layer 3 switch, bottom line. So I've just taken a whole bunch of it and then circulated it all over the environment, my drone environment. And I'm going to be linking them up later with the various cablings that's needed, with that fiber optics or twisted pair cables, whatever you have, you know. Just a whole bunch of them, drop them on your design environment. Pick and drop, pick and drop, pick and drop, pick and drop. Hey, come on, pick and drop. So that's what I'm doing, just picking and dropping like the way we did for packet tracer, you know. Let me look at the diagram of what it looks like. So I got 4 right next to each other, right up here, right up there, and right up here. Too big, just minimize it by clicking on one of the arrows. So I'm just making them smaller so they can fit into my environment. I got a couple of them up there. Okay, one up here. Another one next to it. So we got to pick another one. Right next to it. One down there. Another one next to that. And then we got a couple of them in the middle. So let's minimize it. Sizes of all this stuff. And then we got a one down here, right up here. This could be good that way. This mod that way. Shrink them if they're too big. And let them look even across. That looks too big. So I'm gonna narrow it a bit. That looks okay. Right up here, right up there. So this is what I have. Now to connect them, you just pick an arrow. This is cables. So I do have so there's a line that goes from router 1 to router 2. It's all labeled up. So it's a labeling, it's all using this. So label, this happens to be R2, uppercase R. So that's router 2, router 1. I think router 4 is right down here. And then we did have 3 in the middle. R3. You get a picture, right? I'm just labeling. You get a picture. Anyway, so let's move on to the arrows, the cablings. If you want to connect all these routers in a one space, wide area network space, you can pick the line. So the line will represent your cable. So in this case will probably be maybe my fiber optic cable, and I want a line from here. Move to this. Move to router 2. So from router 1 to router 2, I want one. Let me see how it looks like over here. So we got both front and back. So one, drop it back. And I've labeled the cost associated, the cost metric associated with the both bound packets routes that we have. So from router 1 to 2, I think it's associated with a cost of 1. So we got 1 up here. And then from router 2 back to 1 it has 2 as a cost. So we just put 2 here. So that gives you the cost matrix between routing packets from router 1 to router 2, and then from router 2 to router 1. So the same approach for the rest. Back and forth, back and forth. Oops. Trying to pick up the arrow that I dropped in there, and it's giving me, because it's dead centered on it, it doesn't want to move that quickly. Okay, so let's undo it. Blah, blah, blah. Okay. And then pick the arrow back up. Now from router 1 to router 4. And the cost matrix is 2 and 3. 2 from router 1 to router 4. So 2 here. Oops. I meant to use text. So 2 up here. And then from 4 back to 1, it was 3, right? So I got 3 right here. Okay, so for the loop ones, the ones that loop around, you just pick the loop cables, this right here. So that's the loop cable or the arch cable. I think there was one from router 1 to router 7. So we got this, and then you just pick it up, and then, ooh, that's too big. All right, come on. And then, oh, come on, you're moving not too much, too far. Okay, so we go from here to that. And you can just bend it anyhow you want. So you got your bend. So moving from router 1 to router 2, and then the same coming back. In this case, going back to router 1. And then, oh, come on, man. Try to play nice here. I think I'm using both, which arrows, which is supposed to be the wrong approach. It's supposed to be this way. Okay, so I need to pick you. I need to pick the arrowhead. Okay, this is not playing nice. Pick an arrow from here. Back to 1, sorry. And then just, so you got your back and forth, right? Each one of them has got a back and forth transmission or line across. And from router 1 to router 7 here, so this was 7, this was R7. And so 1 to 7 had what? What was the cost metric? It was 6, so it was 8. 1 to 7 is 8. So we put an 8 over here. And then from 7 back to 1, it was 10, right? It was 10 right there. So 1 and 0, I hope I'm right about that. Yeah, that's 1 and 0, 10. So just put 10 down here. Okay. Are we following so far? Everybody following so far? Type yes, no, yes, no. Let me know what's up. Are we following? Type something, guys. So I'm getting yes and no, yes and no. The guy is saying no. What are you not getting? What are you lost? We're just drawing lines or connecting devices. That's what we're drawing. There's nothing. We're not performing magic over here. The William, the Etel. I'm not performing magic over Louise. I'm just connecting dots. That's all. I have my routers in my environment. And I'm just connecting the dots. That's all. How did I get a 10? It's just a metric. I'm just using, that's just made up. I just made up numbers. Okay, I've just made up numbers to illustrate the cost in terms of moving packets from one device to another. So in this case, to move packets from router 1 to router 7, I've just assigned a cost of 8, a cost matrix. So a matrix, a cost matrix of 8. And then but from 7 back to 1, I've just attached 10 over there. The numbers I just made up. That's all. I'm just made up numbers. They're not, okay? They made up numbers. Lewis is saying the lines. What about the lines? The lines are right up here. I just pick them up and drop. Pick and drop. So I want to connect this device straight line from here, and then I just hook them up. Okay, I'm not doing anything. Yeah, it's just it's like you have your physical router in front of you, and you have your network cable, and you're connecting the ports. That's what I'm doing. Are we good? Hey, next, okay, so there's nothing magical over here. It's the same thing we did for the packet tracer, the same concept, just that we're using a different application over here, which is not a simulator or an emulator, is just a drawing application. So you can be using that for your report purposes. This application is purely used for report purposes. If you are a network engineer and your boss asks you to basically put together a diagram for a network implementation, you want to be using applications like this. And then once you're done, you export them as images, and then you put them in your Word document for your report. That is all that I'm doing. And like I said earlier, there are a whole bunch of applications like this. I'm just using this one because it's free. You don't have to pay a dime for it. And it's called Diagram, okay, by a German company. Anyway, so that's what I did. So that's how I got all of this over here. Okay, so when I was done, I just either capture the screen and then crop it out, or you can export it. So file, export. Export as either a JPEG. It gives you all the options. It's a pretty cool application, so just play around with it. Okay. So anyways, let's go back to the diagram. So I already have this. Let's work with it. So we do have the our MPLS network, which is just a big old one that's been managed by a specific ISP. It could be an MTN, Vodafone, or whatever you know, Sprint, Airtel, T-Mobile. You know them. Okay, you know them, right? Orange from Europe. I don't know. Anyway, it's just a network, okay, by a specific ISP. And I've indicated all the various cost metrics. I've just put imaginary numbers to illustrate the cost associated with various path or routes that you might have to move packet from one device to the other. Okay, so if you go through, you see a whole bunch of numbers. These are just cost metrics. Okay, this is me making up cost metrics over here. On a physical device, it depends on the number of factors, which you can, I mean, if you were to go back to your routing slides, it will tell you the number of metrics or consideration that are used for determine some of these numbers. Okay, but this is just for illustration purposes. So I've just made up my own numbers. Okay, so I got 10 routers. So router 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and I'm using a layer 3 router, a layer 3 switch for my routers. Okay, and I have all the cables connected to them, which indicates the cost matrix. On an implementation, if in the actual implementation, you wouldn't have 2 lines going back and forth. Keep that in mind. You would not have 2 lines. There's only 1 cable. You only connect maybe R1 to R2 with only 1 cable. You're not going to connect with 2 cables. Okay? So please, this is illustration. You're never going to see 1 router having 2 cables connected to the same to a different router. You're never going to see that. Even if it's for redundancy purpose, it doesn't work that way. You don't do that. Just 1 cable is all that you need. But in terms of the back and forth cost matrix, then they would have associated values. So in this case, so if it had been a real environment or in a real deployment, router 1 would say that if I were to move packets from myself to router 2, I want to associate it with a cost matrix of 1. Okay? And then router 1 will say, so router 2 will say, if I want to basically move packets, on the other hand, from myself to router 1, I'm going to associate it with what? The cost of 2, based on a number of factors. Okay? So that's why you have the 2 arrows, just telling you what the routers are basically using, or what metrics numbers the routers are using to associate the various paths that they have for packets to flow through. But obviously, I can't, since I don't want to use 1 cable and be putting 2 numbers on them, I decided to use 2 separate cables and use different arrow points to indicate the direction of the packet flow. Okay, so you notice that from R1 to R2, the arrow is facing R2, and it has a cost of 1. From R2 to R1, the arrow is pointing towards R1, meaning that I'm moving packet from R2 to R2 to R1, sorry, and the cost is what? 2. Are we good on that? Everybody got that now? The guys that were complaining, Louis and Cole. So anyways, so that's how I went about it. So I just associated various numbers to indicate the cost associated all the various path that goes back and forth with the transmission. Okay, so that's good. Okay, the Airtels are getting it now. That's good. That's good. That's good. Great. So we are on the same page right now. That's good. Okay, so now the assumption here to basically put it into question form. So you have this diagram, and then I'm going to come with a whole bunch of questions on this diagram alone, which you have to solve and then give me correct answers. Okay, so the first question is, you have this network, which could be an MPLS network or just a WAN network by an ISP, and it is a customer. So you're a subscriber, so it's me. So me over here, so let's say this is Vodafone MPLS network, okay? And I happen to be a subscriber. And I'm connected to their router 1. So I'm here, so my home is over here. And then my cable connects to this router over here. So I can basically get internet from Vodafone, okay? So I'm here, okay, let me just put a diagram. So in this diagram here, I am here. Let me get a computer here. Or let me use, so let's pick a computer. So this will be my computer, or should I say a modem? Okay, this is my modem. So this is my modem over here. Okay, this is what I have over here, my ONT, my optical network terminal that connects to Vodafone. So I am customer 1. Okay. So that's my modem that links me to Vodafone's network. Very good. So the assumption is I'm a customer connected to router 1, and you want to use the Dijkstra algorithm to basically tabulate all the cost associated with moving packets from my modem through router 1 to every other router within the Vodafone MPLS network. Okay. Are we good? So that's the assumption over here. You have a client, a customer connected to router 1, and I want to know what are the cost metrics using the Dijkstra algorithm to move packets from myself through router 1 to every other router within the MPLS network on Vodafone that I'm connected to. Okay, and you've been given the iterations, the nodes, and their sequence, and then the various routers involved. So since you're on router 1, obviously you're going to eliminate router 1 because you can't point to yourself. So you have to point to subsequent routers. So since I'm connected to router 1, I can include router 1 in my tabulation. I'll have to include router 2 all the way up to router 10. So you got 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then the nodes, which are your iteration sequence numbers, which is the available router that you can move packets through, have all been listed for you. Okay, sometimes you're not going to get listed, but in this case, I've listed it for you just for similars understanding purposes, so we can all be on the same page. Oh, I was using, so it's supposed to be comments. So I've indicated it, the various it was the comma, not dots, not periods. It's comma. So you want to note that in an exam, they are commas, not periods or full stops. Okay. So that's what you have. So I've given you a tabulation. Now we have to basically find or tabulate all the various costs that are associated with moving a packet. So in this case, from customer 1 to every other router X. Okay, so customer 1 to, so moving packets from customer 1 to every other router. I'm using X over here to represent, so R1, R2, R3, blah, blah, blah. Now, obviously, you're going to eliminate R1 because you can't point to yourself. You can't find the cost associated with yourself. It doesn't really make sense. So anyways, indicating all this, so the iteration starts from 0 all the way up to 9. And then the nodes have, so you have node 1, which is router 1, and the second iteration or the first iteration, well, second iteration, if you're counting from in terms of zeros, so 1 will be 1 and 2, so router 1 and 2. The concept here, if we're to be using only one router to move packets across the network, what are the various nodes or routers can you forward packets to? Somebody is saying, sir, please, our screens is blurred. Comfort. If your screen is blurred, it means you probably have a low system resource on your machine. My computer says it's clear as hell. So no, actually it's clear as heaven, right? No. It comes and goes. It has to do with your network. Okay. It has to do with your network. If it comes and go, it means you have a pretty dragging network that you find yourself within. Maybe try and if you're using your laptop, make sure if you're using your laptop, make sure you have other applications. Anyway, I can't control what you see on your screen. It has to be a connectivity problem. I can't control that. Okay, on my screen. It's perfectly okay. I have good bandwidth. I'm using fiber, so I'm getting good connectivity. I'm basically pushing it out to you guys. If you can't see it, it's blurry, then you probably need to find a better connectivity. Okay, we good. Anyways, you do have your nodes illustrated all the various nodes that you might be needing or sequence of nodes that you could use to move packets across the other routers that you have. Okay. So if you only have to move packets from router 1 to all other network, what are the costs associated with it? So let's go through that real quick so we can identify the cost matrix involved. Okay, so the concept here is you're only moving packets from router 1 to every other router. What are the cost matrix? If you were to go back to your your Dijkstra illustrations in your slides, from router 1 to router 2, the cost is just 1. But from router 1 to router 3, it's infinite because you can only move packets from router 1. You only have one router to move the packet. But to get to router 3, you would have to go through router 2, which is not at your disposal yet, because you're only using router 1 to forward the packets, which means that you can only move packets from router 1 to router 2, or router 1 to router 4, or router 1 to router 7, because those are direct connections, a direct device you're connected to. Every other one is beyond your reach. It's actually one more router beyond your reach. So those becomes infinite. So the ones you can reach are infinite. Router 4, it's 2. From R1 to R2 is 2 because it's directly connected to R1. So that would be 2. R5 is all the way over here. You have to go through R2. You don't have R2 yet in the 0 iteration. So it has to be infinite. R6, the same thing, it will be infinite as well, because to get to R6, you need to go through either R2, so to get to R6, you have to go through the R2, R5, R3, R4, and R7, just to get to R6, or even R8. But since you don't have any of those, it'll be infinite. R7 is directly connected. So, and it has a cost of 8 from R1 to R7. So that's 8 over here. Router 8, there are 2 routers that you have to go through, and you don't have them at your disposal. So you have to infinite it. The rest are going to be infinite, infinite. If somebody wants to know, Louis wants to know why there's no R1. So, I mean, think about it. If you are at home, if you're inside your home and you want to send yourself packets, do you have to go out to send yourself packets? No. I'm just using a layman's illustration over here so you can get the concept why R1 is not inclusive, because customer 1 is connected to R1. So it can connect, it can move packet to itself. Are you getting it, Luis? You can't move packets yourself. It doesn't work that way. I was using the illustration of, you being in the house and you want to send yourself packets. Do you go outside and come back? No. I mean, you can't send packets yourself, obviously, because you're already inside. So what's the point? Why would you want to send packets yourself while you're inside? So the same concept over here. If I'm connected to customer one, connected to R1, it can't send packet to itself. So we have to eliminate R1 out of the tabulations because we can't forward packet to ourselves. Okay? So whichever device you're connected to will not be part of the tabulation because of the concept that you cannot forward packet to yourself. So if I was connected to R10, it means that R10 will be eliminated in this tabulation. If I was connected to R6, it means that R6 will be eliminated in this tabulation. It will just be 1, 2, 3, 4, 5, and then 7, 8, 9, 10. Are we getting that? Luis, I hope you're catching on. You can't forward packet to yourself, bottom line. Okay, so the first iterations, we notice that we can only move packets to router 2, router 4, and router 7, simply because we are directly connected to them. We have cables that connect directly to them. Router 2 is a cable that connects to router 2 directly with a cost of 1. Router 4 cable to router 4, cost of 2. Router 3, there's no cable, that direct cable connected to router 3. We have to go to router 2 to get to 3. So it becomes an infinite based on a Dijkstra algorithm concept. So go back to your slides indicated over there, plain. Yeah. So anyways, it's only 3 routers that we can actually forward packets to. The rest are going to be infinite because we can't directly forward packets to them yet. Moving on, so the second iteration, or in sequence of zeros and ones, one iteration, we have 2 nodes or 2 routers to help us forward the packets. So you're going to notice that some of the infinite are going to start missing out. So they're going to start getting values now. So now we have router 1 and router 2 to forward packets. So first, router 2, we still have 1. But look, router 3 now, we can get to router 3 now because we have router 2 at our disposal, because we have 2 to work with. So now what's the cost? So from R1 to R2, it's 1, plus R2 to R3 is 2, which is 3. So 1 plus 2 is what? 3. So that's the cost associated with moving packets from router 1 as a customer to router 3. You go through R1 to R2 to R3. And R1 to R2 is 1. R2 to R3 is 2. So 2 plus 1 is 3. Router 4 will still be 2, because that's the least cost we got so far. Router 5, now watch. We can get to 5 now because we have 2. Because we have 1 and 2. 2 nodes to work with. So what's the cost? It's R1 to R2 to R5. There's 1 and 1, so that's 2. All right. So that's 2. So you notice that the infinite, now it's no more infinite because of the fact that now we can actually get to R5 because of the fact that we have R1 and R2 to help us get to R5. R6, on the other hand, is still far away from us. So it has to be infinite. You need at least 3 routers or 3 nodes just to get to router 6, but we only have 2. Okay. Now, what about 7? It will still be Obviously, 8. So it'll be this 8 over here.